Hello everyone, welcome back. So in this video we are going to understand implement router, right? And this problem is very important based on the past experience of the interview. If you observe, there is a couple of interviews that has asked this type of questions where they want to understand from the candidate that this is a requirement we have given in suppose JSON or XML, and they want to understand how good they are at designing the class and how they understand the data structure. So to understand the data structure, right, we should have the some inputs. Suppose there is not given, but we have given in the uh, definitions we have given here. Okay, let's try to understand how to implement this type of problem. So as you can see, the problem is 33508, and it's saying to implement the router. So the question is saying that design a data structure that can efficiently manage data packet in network router. Each data packet consists of the following route attributes. Very first is source, destination, timestamp. These three things will take when a packet will be uh, when a data packet we will talk about, right? Then we have a implement class router where we will have the router class, and this router class will initialize with some limits, and that limits will be get stored, like you can say, as a maximum number of packets in the router that can be stored at any given time. If a new packet is getting added, if it exceeds the limit, so the oldest packet should be removed to free up the space. Then we have add packet methods that will do adding the packet. Similarly, we have a forward method that will forward the next packet in the FIFO, and it will remove the from the packet, we can. Then we have a get count method, so it will return the number of packets stored in the router. And yeah, that's all we have. So as you can see, the example we have given. So in example, we can say that we have router. Very first, when you write a router, you have to define the what do you call the limits. As you can see, when we write a router, we should provide a limit. This is what we have limit. So when we are adding very first packet, we will pass these three things. Then we'll pass the add packet, another add packet, we'll pass these three things again. Then we call again the add packet, we'll get these three. Similarly for this, for this. Okay, so 5 times we are adding the packets. Then we have a forward packet, we can say. So we will not do anything here, but when we do add packet, add the same thing again. Here we are doing add packet, and then when we are calling the get count, we'll get the get count here. Okay, now based on these operations, like when we are passing, so we are calling here. Very first we created the router object. Let's suppose we are providing the 3 router object, we are passing 3, right? So this is our limit, so the router object will get created. Then we are calling the uh, add add packet, so we are passing these packets. Okay, so this is a very new packet, so okay, let's add it. Then we have another packet, so we are saying 2 5 and 90, it will also get added shortly for the next. So when we add this one, so this on one is already added there, right? So we'll say this is a duplicate packet, will not store here anything. Then we'll add a 3595 again, so this will say okay, the packet is already added. No, this packet is added and return true, so this is the new packet 35, right? Then we have 45, this is also get added. But as you have seen, we have already added these three. Here we have already added, here we have already, here we have already. So the limit is already completed. Now we are going to add a new packet 45 and 105, means I'm talking about this one. So when we are going to add this, it will get added, but it will remove the number of packet exceeded limit, right? It will return true. Then we'll call the forward method, so it will 2590 and it will remove from the router. Okay, so you will free up the second one. We can now you will add 5 to 110, so it will add because you have just removed it. Now you will get the count of this one. So you call this get a count. Only packet with the destination is 5 and timestamp is the range between this and this, so return 1. So this is the what output we are getting here. Okay, I hope you understands. This is very easy problem, right? Now try to understand uh, the intuition. Okay, what data structure we are going to use? As you can see, we will use a queue, right? So queue, or we can say DQ, we will use, and we'll keep these packets uh, in arrival order. So we can uh, evict, or we can say forward the oldest in O of one time, because we have to do that when we are calling the forward, right? We have to evict or forward the oldest one, right, in O of one time. Okay, so we'll use the queue data structure, we can say that. Okay, or DQ, you can also say. Then we'll use a set data structure, so that or you can say hash set, we can say, or ordered set if you prefer, the packet identifier, so that when we'll pass the, let's suppose, source, destination and timestamp. So when we are passing this one, if it is already there, when the second time will be add there, it should not get added directly there, right? It will say okay, it's a duplicate. So if you add, if you use the set data structure, it means it will quickly check the duplicate in O of one time, correct? Then we will use a map of, we can say, destination and the list of timestamp, we can say. So there will be some, like, we can say the map, and we can say there will be some destination, and there will be a list of timestamp, we can say that. Okay, so this will uh, so this will use, this map we will use to store the timestamp for each destination we can. So because when we add the packet, right, when we adding the packet, right, timestamp are non-decreasing, right? 90, 90, 90, 95, 105, like that we can say that. So you can append timestamp and the property destination list stored, we can say, in the sorted form, right? We can say that. Then we'll use another map that will take care of let's suppose the destination and the process index. Here we will use the process index. Okay, it will count how many oldest timestamp that destination has been removed for the forwarding or evict. The processed index will get the count, and it will ignore already and will remove the timestamp with the physical physical deleting from the list, we can say, without physical deleting from the list. So it's also will make you that delay, we can say, as a kind of. So this is what we are going to implement. So let's try to understand how to implement it. So very first, what I told you, that we will use the maps, right? So this is the very first map that we will use for the map, and we can say list of integer, means this is our destination, and this will be our list of we can say the timestamp, right? So this we will use for a destination timestamp, we can say map, that will store the timestamp for each destination, because uh, add packet timestamp are non-decreasing, and we can append timestamp, and will do per destination list stay in the sorted form, right? So we'll say okay, destination, there will be a list of timestamp, and it will be sorted per append, we can say that. And then we have a process count. We will use integer, and integer means it will be a destination, and there will be a process index, we can say that. Okay, we can say the destination and the number of earliest timestamp to remove, we can. Okay, then as I told you, we will use a set data structure. So set data structure we will use as a, we can say, hash set, we can take, right? Or you can say, yeah, we can take the hash set here. So this hash set we will use uh, uh, remove, you can say, to find the duplicate quickly. So we'll use the hash set. Okay, and then we will use a queue, or you can say DQ. So let's suppose we'll take the queue data structure. It will keep the packet in arrival order, so we can evict or forward in the oldest, you can say that. Then we have the timestamp, that memory limit, and that memory limit will we will provide for the object initialization router. Okay, so these are the things that we will do for initializing the these values, we can say that. Okay, so let's suppose this is our helper function, and we'll pass source, destination, and timestamp, and we'll form a string, we can say that. Okay, so we'll have our unique key when we'll store the on the scene, right? We can say scene will be our set data structure, you can say, where we'll store. If the next data structure is coming with the same key, we'll find out, okay, this is the duplicate one. So let's understand how the we will use the evict, means we will remove the oldest packet from the storage. Very first, the queue, we'll add everything on the queue. So we'll say, okay, poll first, you will get the things. If it is not null, in that case we will find the key, we can get the key, we will form the key, this is our key, and we'll say scene dot remove key, and we'll remove from the set scene. And then we will process the count. We'll say, okay, let's add the process count, and we'll add our destination, we can say, and we can get the process count like this. Come to here, the packet one. So this method will do what? We will add the packet with the source, destination, and timestamp. Very first, we'll create a key. We'll check on the scene if it is a new. In that case, we'll process and we'll check the limit also. If limit exceeded, then we will remove. Otherwise, we will create a queue, right? We'll add on the queue, and we'll add on the scene. Means we have just seen this because we have added on the queue. Now we'll find the timestamp. To find the timestamp, we have to add every time. The timestamp we will find in the monotonic non-decreasing guarantee it will give you, right? So we'll okay, the timestamp compute absent, will pass the destination, and this list will be get appended by the timestamp. Similarly, we'll do the process count, we'll add the destination, and we'll find the process count index, we can, means the process index, we can, and we'll return true. Similarly, for the forward method, we'll check the forward method. I will say, okay, if queue is not empty, then if queue is empty, return this as a index one. Otherwise, you uh, get the p from the recall a packet from the queue. Prepare the key, remove the key, process again. Will process the you can say destination with his count. We'll say this is also process and return the p. Then we have the lower bound. You know how to find the lower bound. You don't need to explain this one. Then we have upper bound. Similarly, we'll find the upper bound. These are to find the limits, right? Upper limit and lower limit. So when we are calling the get count method, at that time we need this lower bound and upper bound, so we can find the range. Okay, and for that we know that we already have the timestamp, right? So we if we'll provide the timestamp on the map, we can get as a key, we'll get the timestamp, list of timestamp. What we need to do, we check timestamp is not empty, we'll process this timestamp, we'll mark it as 0, and we'll find the lower bound and upper bound, and we'll return the count in this range, in this timestamp. What are the we can say range, what are the how many counts are there, so we'll return how many currently stored packet have the given destination and timestamp in inclusive range will return. So to test in your Eclipse, what you need to do, just create the main method and check this functionality. Let's suppose we have a router with the 3 objects. We'll pass very first is first packet 1490, and second packet again you will pass, so it will say okay, return true. Then you pass the same thing that we have added here, it will return false because we have just added. Then we'll try the another one. Okay, so now it will get added. Now the limit is exceeding, right? Limit is 3 already, 3 packets we have already stored. So next when we are going to add another packet, it will return true and it will evict the oldest one, right? So if you find the forward methods, we will get what is the forward method. It will give you 2590. It will give you, it will return, okay, because we have to check what is on the forward one. Okay. Then when we call the add packet again, it should add because again we have just forwarded one of them, right? Then we can get the count. We can provide the range. In this range, what are the things are there, it will return you. Okay. So this is what we need to develop, right? I hope you understand this one. Very easy problem, right? Where you have knowledge of basic data structure, you can implement this route. Collection framework, you can say the collection framework. Anyways, thank you for watching this video. I'll see you in the next one, and till now, bye bye.